Okay. When I'm looking at this one, James, interesting. You had your head down. Now you put your head up when you're looking at your phone. So if you guys notice with this triangle, do you guys see how this is a side-side angle? Okay? Or angle side-side, haha. If you, what this can be, this causes our ambiguous case. Causes our ambiguous case. And what I mentioned was, if you, whenever you have this, the reason why is because if you guys look at this triangle here, let's pretend I have a side length. Let's do, I don't know, 25 degrees, 10, and 3. I'm just trying to give you guys an example of something. So actually, we don't need this other one. What I want to show you guys is this ambiguous case is whenever you guys have an angle side side, it is possible that that side length that we chose is not long enough to actually make a triangle. Remember when we did the sine inverse, not within the domain, right? If you try to do sine inverse of a number less than 1 or greater than 1, you're not going to be able to find an angle. So therefore, that side length, whatever side length that was given in your problem, is actually not long enough to create a triangle. OK? So we'll get to it again. But I just want you guys to understand, when you have an ambiguous case or a side-side angle, it's possible to have no triangle. OK? It's possible that there's not a triangle that exists with those side lengths. I'll show you an example, but we'll go through it. Over here, it's possible to have a triangle where there's 2 cases. And this is the problem that we're going to do. In this problem, do you guys see, if I rotated this, do you guys see how 8 is still 8? Yes. But now I have 2 different triangles. It's the difference between having an obtuse triangle with an acute triangle, where all the side lengths are acute. But you could create, there's 2 different triangles. You could have one where the red is that side, or the triangle looks like that. You guys see the difference? OK, so we have to be able to determine, how do we know if there's 2 triangles, or when are there 2 triangles, right? Well, first of all, let's go ahead and find out our measurements first. So just like I did before, I always like to sketch a small little triangle, just see what everything looks like. So I have B. Now let's do A, B, C. We have little a, little c, and little b. So we know B is 21, big B is 38 degrees, and C is 25. Does everybody follow me? Yes. So we have a ratio now that we're going to use for our law of sines. So therefore, in this case, we know that our ratio is going to have to contain C and B. We don't have any ratio with A, so we're not going to be using A. So therefore, I will do that 21 over the sine of 38 is equivalent to 25 over the sine of C. I'm trying to save some work because this problem is going to take up a lot of space. So does everybody see how I got these 2 ratios? I did B over the sine of B. E is equal to C over the sine of C. Is everybody OK? Yes, you can use my whiteout. Now you go ahead and solve. Now again, as I mentioned before, you can cross multiply. I'm just not going to show my work, and I'm just going to solve at least for sine of C. So sine of C is going to equal 25. Why was it so much easier when I was going through this?
25 times sine of 38.
Right.
Also about sine of 38 on both sides.
OK. Now, again, just go through with your calculator and just do 25 times the sine of 38, and then divide that by 21. So I have the sine of C equals 0.7329 dot, 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 dot.
Would you multiply by sine of C? Or sine of 38?
I did 25 times sine of 38, and then divided by 21.
Yeah, when you solve, like, did you multiply by sine of C on both sides, or sine of 38?
Yeah, you multiply by sine of C. It's much easier to probably do this. Yeah, you got to multiply by sine of C on both sides, and then multiply by the reciprocal on both sides. I can show you over there, but I'll show you.
I thought it was like 20.
I'll show you how to solve for that. Nothing.
Yeah.
Here's it.
Mr. McLogan,
Yes.
I need Marina Wood to check out in the front office, please.
Okay.
Thank you.
Just make sure you write down the homework, okay? So now we have sine of c equals this, but we need to figure out what c is. So therefore, we have to use inverse, right? So we do sine inverse of second answer, and I get 47.13. Again, I'm just going to round to the 10th. So c equals 47.1. Does everybody follow me? Right, because guys, remember what I did? Sine of x equals 1/2. How did we figure out what x was? Remember when I did this beginning of class? We did sine inverse of 1/2. We did use the unit circle, but I also told you to check your answer with your calculator, right? And by checking your answer with the calculator, you get x equals 30 degrees, correct? This is the same thing, but instead of 1/2, you have 0.7329 or some crazy decimal. So you just do sine inverse to find c. Correct. I just used the whole answer in the calculator. Does everybody follow me, or anybody have any questions before we move on?
Yeah, just solving fun. Like,
I'll show you that thing. Just write it down, and I'll go over that again. Is everybody okay with this? At least with this. Now, remember, though, when we did this, when we did the sine of 1/2, we figured out there was two angles, here and here, right? But the calculator only gave you the two angles in the domain. Or it only gave you the one angle that was within the domain of the inverse. There's two answers. Your calculator is only going to give you one answer. Since this is a side-side angle, we need to determine, is there another angle that works? So what we're going to do is we're going to look for c prime. So to find c prime, what we're going to do is take 180 minus 47.1. Now follow me on this. Again, remember, if this was 30 degrees, then we knew that was 30 degrees, right? How did we find out what this angle was again? You just did 180 minus 30, right? So if I'm saying this is 47 degrees, to find what the angle is, you just do 180 minus 47.1, right? So therefore, this is going to be a 132.9? No, it should be 30, yeah. Equals 132.9 degrees. Now, could that be a triangle as well? Or could that be your angle? So could this be 132.9? Is it possible? Well, let's use the sum of angles. Could you have this be 132 and this be 38, and could we still find an angle for A?
yeah.
Yes, again, don't be confused by what my triangle looks like. But yes, you guys could still do it, because watch. Now, we have case 1 and case 2. So when you have this happen, you write case 1. You're going to be c is equal to 47.1 degrees. And then you have case 2, where you're dealing with c prime, which is equal to 132.9 degrees. There's two different cases. Yes?
Why wouldn't you just put in 47.1 in for C and then be done with it?
Because as I'm mentioning, just like I said, why don't you just do the sine inverse of 1/2 and just get the answer of what your calculator is, which is 30 degrees. Because as I mentioned, there's two answers. Both those work. This is, square root of 3 over 2, comma 1/2, or negative, right? This is square root of 3 over 2, comma 1/2. The sine of both of those angles is 1/2. So there's two answers, right? They both work. But your calculator only gives you this one, because it's within the domain of the inverse. So the same thing, you got to check it, all right? Always check it. And I'll show you guys, I'll show you an example of when it wouldn't work next, after this. Anytime you have a sine-sine angle. If it's angle-angle-side, you don't need to worry about it. But when it's side-side angle, you always have to check. And that's what you're doing in your homework for 13 through 18. That's all you're doing is just checking. OK, so now we still got to solve both of these. So we have case 1 and we have case 2. So for case 1, what I always like to do, again, ladies and gentlemen, is just draw the triangles again. I think it's so much easier just to be able to realize. Now, you guys could say, well, I already have the triangle drawn. That's perfectly fine then. Just leave it like that if you like. So therefore, this would be 47.1 and 21. And what was A? Did we know A or C? C is 25. B is 38. B is 21. C was 25. Where's 25? Oh, there we go. OK, so now, again, by using all there, could we figure out what angle A is? Angle A is 180 minus 38 minus 47.1. So I just do 180 minus 47.1 minus 38. And that's 94.9. Does everybody follow me? So therefore, I fill that in, 94.9. Now, the only thing I don't know is the sine length A. So can I use, again, the law of sines? Sure. So I just do A over the sine of A is equal to, just put that in that top box. Oh, back over there. Sine A over the sine of A is equal to, now we just need to create a ratio. Again, I would prefer you use ratios that you've already used before, which would be 21 over the sine of B. So we're trying to solve for A. Oh, I'm sorry, sine of B, which you already know, which is 38 degrees. So therefore, by using your multiplication or solving techniques, A equals 21 times the sine of A. We already knew sine of A, 94.9. All over the sine of 38. Is everybody OK with how I got those values? Does everybody know where these values came from? This is A over sine of A. A, we figured out, was 94.9. Over B, which is 21, over sine of B. B was 38 degrees. Sine of, right? So now you just do your calculator. Do 21 times the sine of 94.9. And then divide that by the sine of 38 degrees. And I get 33. A equals 33.9, so that actually be 34 when you round it. Does that look correct, roughly? Does that look about right? It's not like 34,000, right? It's about good. All right, so now we get into case 2. Case 2, you're doing the exact same thing, but now we're using C prime. So you're going to do the exact same thing. We still need to figure out A. A is now going to be 180. Oops, I'm sorry. Create your triangle. It's helpful when you're doing two cases to draw your two triangles so they actually look like what they're supposed to look like. So for instance, this one, I would say there's my C. Here's my A, which I do not know. Here's my B, which is going to be 38 degrees, and then 21. Oh, this one's 25. So now I need to figure out what A is. So that's going to be A equals 180 minus 132 minus 38 degrees. These angles should probably be a little bit switched. And that's going to be A is equal to what? 10 degrees. Does everybody follow me? Huh? Have to do both ways?
The case 1 and case 2.
Yes. Yes. They're both possible. They could be both of them. Huh? Where 0.9? Oh, I had left that off. Thank you. So therefore, it's going to be 9.1? No. Yeah. Thank you. So that's 132.9. All right, so now we do law of sines with this. How much fun, right? So you do 9.1 over the sine of A. Do we know sine? Oh, wait, this is your degrees.
Yeah.
Sorry, we don't know what A is, right? So it's A over the sine of 9.1 degrees. Hence, it's really important not to make these mistakes by using the uppercase and the lowercase, as well as making sure you do the degree symbols. Because doesn't 9.1, that you'd think of that as like a side length, right? That's actually your angle. My A and B should really be flip-flopped for this triangle. OK? They should be. That's 9.1 is really up there. But it's not really the most important thing at this point in time. And then we just do b, 21 over the sine of 38 degrees. So when you go ahead and solve for this, you're going to have a equals 21 times the sine of 9.1 degrees all over the sine of 38 degrees. So again, going back to your calculator, you do 21 times the sine of 9.1 divided by the sine of 38. And that's going to be 5.4, approximately. Which really should have been flip-flopped around there, but that's it. So to recap for this problem, whenever you guys have side-side angle, once you find your initial angle, make sure you subtract it from 180. This only works for side-side angle. Make sure you subtract from 180. If that angle, you can add it to both of them. Excuse me. Then you have two cases. And you have to solve both cases separately. You guys only have one of these examples on your homework. OK? So that's not